Relations and functions. Let's start with some vocabulary. A relation is a set of ordered pairs. For example, in this case, S is a relation with 3 ordered pairs. 1, 2, 3. You might also know these as coordinates. In this case, we have X values of 0, 4, and 4, and we have Y values of 8, 3, and 6. So for the X values, 0, 4, and 4, 0, 4, and 4. You don't have to write 4 twice because that's redundant. This covers all possible X values. And then we have the Y values 8, 3, and 6, 8, 3, and 6. This is our map over here. And what the map does is it shows you which X values go with which Y values. So in this first ordered pair, we have 0 and 8. So we have X value of 0 maps to the Y value of 8. And then we have 4 and 3. So X value of 4 maps to a Y value of 3. However, we also have another one that has an X value of 4. So 4 also maps to 6, like that. In example 2, T is a relation with 4 ordered pairs. 1, 2, 3, and 4. The X values are 1, 3, 5, and 6. 1, 3, 5, and 6. And we have Y values of 8, 6, 6, and 3. 8, 6, 6, and 3. And then we also have them mapped. So an X value of 1 maps to a Y value of 8. 1 goes to 8. 3 goes to 6. 5 also goes to 6. So X value of 5 points at a Y value of 6. And X value of 6 maps to a Y value of 3. So these maps will help you visualize what you see when you see one of these sets. Here's some more vocabulary. A domain is a set of allowable inputs or arguments. In this case, the domain would be X, all of the X values. And the range is the set of achievable outputs or values, which are, in this case, the Y values. So in this example, with the set S, we have the 3 ordered pairs, and we have our map that shows which X values go to which Y values. And in this case, the domain would be all of the X values, and the range is all of the Y values. So here, the domain of S is 0 and 4, those 2 values, and the range is 3, 6, and 8. In our second example, we had 4 ordered pairs in T. The domain is the X values, and the range is the Y values. All right, so now we get to functions. A function is a relation in which each input has one and only one output. Remember, a relation is a set of ordered pairs. In this case, S is the relation. The inputs are X values, and the outputs are Y values. So in this case, each X has to have only one Y. But as we can see from this map, 4 maps to 3 and to 6, which means that this is not a function. In the other hand, we have T, and T is a function because each input, or X value, has one and only one output, which is a Y value. So, see how each value of X, you can draw only one line to the Y category. Each X has only one Y output, and that means that this was a function. Function versus not a function. Let's imagine a soda machine. For every button that you push, an input, there will be one type of soda that comes out. So it doesn't matter if there's 2 different buttons for cola, one cola is going to come out, no matter which button you push. This is kind of how functions work. For each input, there's only one output. So if you push a cola button, you will get a cola. If you push this cola button, you will also get a cola. But you're never going to push a cola button and get a cola and a Diet Cola. That would not be a function. So this is a helpful analogy. All right, so let's get started with some examples. Determine if each of the relations below is a function and provide an explanation to support your answer. All right, so the first thing we're going to do is draw a map of this relation. All right, so based on this map, is this a function? We can map 1 to 3, 4 to 7, and 6 to -1. So this is a function because each input maps to exactly one output. All right, next one. Here we have another set of ordered pairs or a relation. Draw the map. Here we go. There's our map. All right, so 2 maps to 4, 3 maps to 4, 5 maps to 4, and 6 maps to 4. They all point to one output. Is this a function? It is, because each input has to map to one output. So it doesn't matter that they all point to this one output, that each one of these just needs to point to one number. All right, and the final example. Here is a relation with 5 sets of ordered pairs. First, you draw your map. All right, so let's map this out. The input value of 1, oh no, it maps to 2 separate values in the outputs list. So I can tell you right away, this is not a function. Because remember, each one has to map to only one number. So if one x value here maps to 2 separate y values, that is not a function. All right, let's determine if each of the relations below is a function and provide explanations to support our answer. All right, here's our first relation. We have -1 maps to 5, and we have -1 maps to 9. So what do we know about that? It's not a function because one x value cannot map to 2 separate y values. All right, here's the second example. -2 maps to 4, 3 maps to 4, and -5 maps to 4, and that is a function because each x value only has a line to one y value. Okay, and for the third one, we have 2 maps to 8, 3 maps to 7, and 4 maps to -3, which is a function because each x value only maps to one separate y value. State the domain and range for each relation and tell whether the relation is a function. All right, the domain is 2, 3, 4. The range is 7, -3, 8, or if you want to put it in order, -3, 7, 8. Each x value maps to exactly one y value, so therefore this is a function. Here we have a domain of -5, -2, 3. They all map to one single y value, which is allowed. Therefore, and the range here is just 4. Therefore, this is a function. Here, however, we have a domain of -1 and 2, but a range of 5, 8, 9. Here you can see one x value has 2 different y values. Therefore, this is not a function. And here are the answers.